Hi, welcome to this lesson on trigonometry compound angles, question 6. We want to prove that the sine of a plus b minus the sine of a minus b is equal to 2 times cos a sine b. And then we want to evaluate this expression without the calculator. Okay, so let's go ahead and prove that the left-hand side is equal to the right-hand side. So the left-hand side is sine of a plus b minus the sine of a minus b. So let's go ahead and expand those out using the compound angle formulae. So for sine, it was sine cos, cos sine, okay, AB, and then because of the plus sign, we put a plus in the middle, minus, and then again we have the sine, so it's going to be sine cos, cos sine, and then the angles AB, in the order that we see them, and then because of the minus sign, it's a minus. So let's see what's common here. Sine A cos B, sine A cos B. We're subtracting them, so those will cancel. And then we have cos A sine B minus minus, so it becomes plus cos A sine B. And that's exactly equal to 2 amounts of cos A sine B. And that is exactly the right-hand side. So we have successfully mathematically proven that that identity is true. Next, we want to evaluate this identity. So now look at this. We have a cos and a sine. All right, cos, sine. Here we have a cos and a sine. So if we can put these angles back into the left-hand side, we can see if we can evaluate this. So now notice there's no 2 in front here. So that's important. So cos of 75 times the sine of 15 degrees, I could write that as, well, instead of, so it's going to be cos A times sine B. So your A here is your 75 degrees and your B here is 15 degrees. So therefore, from this identity we've just proven, I can rewrite cos A sine B as a half. So I divide both sides by 2. And I get a half times the sine of A plus B minus the sine of A minus B. Okay, this is actually a nice trigonometric identity we've actually proven here called a half angle identity, right? And it actually gets used in very complicated looking trigonometric problems, right? Especially at a university level as well. Okay, so we know what A and B are, right? A was 75 degrees and B was 15 degrees. So if I just plug that in, so cos of 75 degrees times the sine of 15 degrees, that's a half times the sine of 75 plus 15, that's 90 degrees, minus the sine of A minus B, 75 minus 15, that is 60 degrees. Okay, and those are special angles. Sine of 90 degrees is 1, and sine of 60 degrees is root 3 over 2. So if I simplify this, it's a half times, okay, if I'm subtracting fractions, the LCD here is 2, so it's going to be 1 times 2 minus root 3 times 1, okay, all divided by 2, okay. That's doing a lowest common denominator and then subtracting fractions. So therefore, the final answer is equal to, it's going to be 2 minus root 3 in the numerator, and then the denominators we have a 2 times a 2, which is 4. Okay, and we can double check if that is correct, right? So let's bring up our calculator. Cos 75 times sine of 15. Okay, and there we go. 2 minus root 3 divided by 4. Okay, so that's how we know algebraically we have derived that answer correctly. Alright, so that's how we would solve this type of question. I'll see you in the next one.